Okay, unfortunately, I made a 7-minute video and it froze on me, so that stinks. So I'm going to have to talk about the problem. This is the answer to number 19. We've formed the box here. We've got 4 going across. We got, 2 on each side. So 2 this way, 2 that way. This guy's going to be 4 this way, 4 that way from the center. And with a hyperbola, we make sure that we form the box. X is first, so we open up this way, and that's it. That's all she wrote. That'll be good. So just, pause the video then to take a look at that. Make sure you got that. This guy right here, we have invisible 1s underneath both of those, but the y is first. And remember, with hyperbolas, with subtraction in general, order is important. So you're going to have your curves going up and down. And so that's what we have here. So we have a little box that goes 1 this way, 1 that way, 1 this way, 1 that way. But they're going to the midpoints of the boxes. So when you draw the box, it's actually going to be a width of 2. Remember, the spine that has the vertices, that's called the transverse axis, and the spine that doesn't have the vertices, okay, they're not even called co-vertices, because with an ellipse, co-vertices have, they have points, right? But these are not points, and so they call that a conjugate axis, okay? So that'll come up later, okay? So that's what this guy looks like. Going here, I think the best thing to do is graph these guys. This says endpoints of conjugate axis are here, but if you notice vertices, that's kind of telling you the length of the transverse axes, okay? The vertices have the actual vertex, right? They are the vertexes. So that's a vertex, that's a vertex. So they have to be on the transverse axis. So once you figure that out and know that, a -1 is this way and -7 is that way, you can see that 3 is here, 3 is over on that side. So therefore, 9 is going to be going underneath the x because these guys are going back and forth. Okay, they're going horizontally because the y-coordinate is not changing. Okay, here the x-coordinate is not changing, so that's going up and down. Okay, but the reason why we're putting 100 underneath this guy is because this is saying that it's the endpoints of the conjugate axis. So it doesn't have the vertices, and so it's going to go up and down. Okay, the vertices that do have it are going across. All right. So anyways, with that explanation, hopefully that would explain this guy. So this is his equation, but you don't have to put -0, just put y squared. But, if the conjugate axis is 6 units long, you know that it's 3 this way, 3 that way. So therefore, it's a 9 that goes underneath, not a 6 or a 36, okay? So this guy, cut him in half, so 3 goes that way, 3 go that way, and then that 3 gets squared, okay? So just try to remember that. All right, what else? Was that it? That was it for that video. Okay, so that was a 7-minute video described in 3. What we'll do here is I will do just a couple more just for this video since we got the 3-minute mark. Okay, this guy here is a hyperbola, obviously, but we need the foci. So the foci are going to be, let's see, x's are first. So the foci are going to be those points that are kind of right there on the inside of the curve. And so the formula for that guy, okay, is c equals the square root of a squared plus b squared, okay? So the hyperbola with subtraction here for the formula of the foci, you're actually going to do this. And you can notice that is the Pythagorean theorem, okay? So let's go ahead and get that. The a, it doesn't matter actually what order, so we know we're going to have the square root of 169 plus 25, and I just don't trust myself. 169 plus 25 is 194, and you can see a couple of square roots of 194 here. So where does this guy go? Okay, well, the c value is actually this distance, okay, right here to here, okay? So what's going to happen is when you have the top portion of the vertex, okay, the top vertex, you're going to add radical 194 to the y-axis, or the y-coordinate, okay, because you're going up. this guy, you're going to take that vertex and add this radical 194 to the y coordinate going down, okay? So in what you're subtracting it, right? But if it's negative, it'll just stay negative. So let's see how this works. This right here tells us that the vertex, okay, the vertex is not the center, so let's get that straight. The vertex is going to be, the center is going to be 5, 13. What am I doing? Oh my God, nope. C is -3, -10, okay? So, oh, wait a minute, oh my God, it's not adding to the vertex, it's adding to the center. So it's this distance. Okay, so it's not to the vertex. I'm sorry. I think I said that about 3 times, vertex. No, you're adding it to the center. So we are going up from this guy. So if this guy is -3, -10, we're going to go -10 plus radical 194 and -10 minus. So let's see if we can find it. Okay, there's -10 plus, -10 minus. That's our guy. Is he -3 for the x-coordinate? Yes. Okay, so that is the guy. The answer is C. Okay, I'm so sorry I said vertex. Okay, it's from the center. All right, so that's kind of complicated, but if you draw a picture, just remember the C value is this distance from the focus to the center. Okay. All right, because that's how it is with the ellipse as well. All right, now E equals C divided by A. So let's get that C there. We know that the C value is 49 plus 36. What time is it? So 49 plus 36, radical 85. Okay, I see them right there, lots of radical 85s. Got 2 of them right here, but it's going to go over A. So to go over A means you are putting it over the largest of the 2. Okay, this is actually B squared, and this is A squared. So remember, A is always going to be the larger one. So really, it's going to be over 7. Okay, and you can see that they've got both options here. Are you going to put it over this guy, or are you going to put it over this guy? Well, you put it over the larger one. Okay, so eccentricity is 1.3. So for hyperbolas, they can be greater than 1 because you've inverted the whole process. Okay, in fact, they can be infinitely large, quite frankly. Okay, in fact, the closer it is to 1, the more it'll look like that. Okay, the farther it is from 1, the more it'll look like that. Okay, all right, I'll stop right there.